Hi everyone. Okay, so this is day 2 of circles and angles. You have a warm-up in front of you, or you should have a warm-up in front of you that looks like this. It's kind of like the last two problems that we did yesterday. I want you to label every angle and every arc that you can find in both of them. I highly suggest that you try this on your own and then come back and I will show you the answers. So pause it right now, and then I will explain how I got these. Okay? Okay, so this is what all the angles and the arcs look like for this first circle. Some places it's kind of tough, so I thought I would stop here and show you guys. Um, so I started first with finding the arc CB, and I showed my work off to the side. I just took 360 minus this angle and minus this angle, leaves you with 101. And then if that arc is 101, then this angle is a central angle, so it's also 101. And if this is 101, this is an inscribed angle to that same intercepted arc, so it's half of that 50.5. Okay. Coming back to this angle of 101, this is an isosceles triangle. Since these two segments are congruent, since they're both radii of the circle, that means that then isosceles triangle, these two angles have to be the same. So if you do 180 minus 101, divide that answer by 2, you get 39.5. Okay, and then these two angles, this 33 and 17.5, are actually really tough to get. So nice job if you got those. What you would have to do is you would have to see that this angle right here is an inscribed angle for this arc. So if this arc is 145, half of 145 is 72.5, and you already have this angle right here, so you subtract 39.5 from 72.5 and you get 33. For this 17.5, you can see that this is an inscribed angle, and it opens up to this arc of 114. So you would take 114, divide it by 2, since it's an inscribed angle, which gives you 57. And then you would take 57 and you would subtract the 39.5 degree angle that you already have, and that's what leaves you with 17.5. All right? Okay, great. I'm going to do the next one, so pause it if you haven't done it already. Pause it now and try it, and then I'll come back in a second and show it to you. Okay, so here's what this circle looks like. You can start in a couple different places. I started with this angle of 36 and said it was inscribed. So if this angle is inscribed and it opens up to this arc, double that, this has to be 72. I also saw that this right here is a diameter. So if that's a diameter, this is 72, this is 52, then subtract from 180, this has to be 56. And then you have every arc except for one, so you can do 360 minus 72 minus 52 minus 56 minus 49, and you get your 131. Okay. From there, I saw that if this is 49, this arc right here opens up to this inscribed angle, so half of 49 is 24.5. Right, and then you have a triangle right here. So if you know two of the angles, subtract 36 and 24.5 from 180, you get 119.5. Right, I'm actually going to get rid of that because it covers up some of the numbers. If that's 119.5 vertical, so is that. These two are supplementary, so subtract from 180, which gives you 60.5. Vertical, that's 60.5. Okay. If this angle here is 56, then this is a central angle to it. So this is also 56. And if this is 56 and this is 60.5, this is a triangle, so subtract 180. This is 63.5. Vertical, that's 63.5. Supplementary, those two are 116.5. If this is 56, supplementary, that's 124. All right. Let's go on to the notes. All right, so today we're going to add on one thing, and it's arc length. So half of our notes are going to deal with what arc length is, and then the other half is going to go back and start talking more about central angles and inscribed angles. Okay, so circumference is we talked about this yesterday, is the distance around a circle. Your formula is circumference equals 2 pi r. I always remember it as twinkle, twinkle, little star, circumference equals 2 pi r. All right, so what is the circumference of a circle with a radius of 10 feet? So if you got a circle, here's a radius, and this is 10, then we would say that the circumference equals 2 pi times r, which is 10. There's two ways that you can write this answer, and I'm going to ask for both in certain situations. One of them is to keep it as an exact answer, and 2 times 10 is 20 pi. And then since this is in feet, this is also feet. Since it's a distance, it's not squared. Or you can say that the circumference is about 62.83 feet. Make sure you use the pi button in your calculator and not 3.14. Okay, so either one of those, it just depends on how the question is asked. Okay, so arc length. We talked yesterday about arc measure, and whenever we talked about an arc measure, the measure of an arc, when it was written like the measure of arc AC, then we said it was like 80 degrees or something like that. But measure had to do with angles. When we talk about an arc length, it's talking about the actual distance. So that means that we're talking about circumference. So instead of the whole circumference, we're talking about just a part of the circumference. Okay, for instance, if this was my circle and the circumference was 20 pi, like in the last problem, and let's say this was a diameter, and this is still your 10 of your radius, okay, if I wanted to find the distance of the arc length of half of my circle, I would say, well, my circumference is 20 pi, and that's half of my circle, so I want half of it, which means my answer would be 10 pi. Okay, so arc length is really just a fraction or a portion of the circumference. So, I mean, you can really think about it as like your arc length equals your circumference, 2 pi r, times theta out of 360. Remember, theta represents an angle, so some angle out of 360. Okay, so let's use this as an example. If this angle is 70 degrees, then this arc is also 70 degrees, since it's a central angle. So if I wanted to find the arc length of this arc, so the measure of this arc is 70 degrees, the length would be, the arc length would be 2 pi times my radius of 3, and then times, I don't want 360 out of 360, I want 70 out of 360. So my fraction or portion that I want is 70 out of 360. There's two ways that you're going to write your answer. One is an exact and one is an approximate with 2 decimal places. Whenever you do an exact, this all is a fraction over 1. Multiply your numerators. So you do 2 times 3 times 70, which is 420. And notice I skipped over the pi because giving an exact answer is pi in the answer. So it would be 420 out of 360. And then I'm going to simplify that, and I can do that in my calculator. So remember that you would do 420 divided by 360, forget about pi, and then you would change that into a fraction. So I would get 7 pi over 6, and this is in feet. So that's my exact answer. Or my approximate answer, so I'm going to say about, is actually just multiplying 2 times pi times 3. Make sure you use the pi button. And then times 70 out of 360. And that gives me about 3.67 feet. So either one of these answers, depending on how the question is asked. Okay? So let's try. What is the length of an arc with a central angle of 100 degrees and a radius of 5.5? I would suggest drawing this out. So if here's my circle, here's my radius, so actually it's got a central angle, so it looks something like this. So if the central angle is 100 degrees, then that, if the central angle is 100, so if this is 100, then that means that the arc measure is also 100. It's got a radius of 5, so my arc length is equal to 2 pi r, so that's my circumference, times some portion out of 360. Okay, I suggest writing the formula a couple times. So I'm going to say 2 pi times my radius of 5.5, and then I want this right here, which is 100 degrees, out of my whole thing, because the arc length that I'm trying to find is this purple part right here, not the entire circumference. Okay, so then I'm going to say times 100 out of 360. Alright, I'm going to find the exact answer for this. So in my calculator, I'm going to do 2 times 5.5 times 100, which gives me 1100 pi out of 360. I'm going to let my calculator simplify that for me. So I'm going to just divide 1100 by 360, and then I'm going to change that back into a fraction, and I get that my arc length is 55, don't forget your pi, out of 55 pi over 18, and that would be centimeters. And that's your answer. Okay, let's try again. So this one says, what is the length of an arc? So again, length, not measure. What is the length of an arc with an inscribed angle of 100 degrees? So this time, my circle, I have an inscribed angle, so it's got to hit the vertex has to hit the circle. This is 100 degrees, which means if this is 100 degrees, I have to double this to make this 200 degrees. Okay, and it's got a diameter of 5.5. So arc length is equal to 2 pi r, so it's my circumference, times some portion of 360. So this is going to be 2 pi times r, but be careful, I have to divide this by 2. So I get 2.75 times 200 out of 360. Okay, again, it's 200 out of 360 because I'm finding this portion of my circumference. Okay, that angle tells me what portion I want, or what fraction. Okay, all right, so this one I'm going to give an exact answer as well. So I would do 2 times 2.75 times 200, which also gives me 1100 out of 360. There's a pi up here. And that was the same thing that I got before. So I know that that's going to simplify to 55 pi out of 18, and then centimeters as well. So notice that this actually gave us the exact same answer, and the reason is because if I look back at my formula, I had 100 over 360, which I doubled to 200 over 360, and this was 5.5, which I cut in half to 2.75. So they end up all multiplying to give you the same thing, since I doubled one number and cut in half the other. Okay? Okay, let's try another one. This says, what is the length of arc AD? Okay, again, notice it says length, not measure. So that means we should be thinking length, circumference. Round your answer to the nearest 100th place. So in this one, we're going to round. Okay. What is the length of AD? So here's AD, and notice that there's two ways that I can go with AD. I can go this way, which is not possible because I use 2 letters, and that's a major arc. So then that means that I must be going this direction. Okay, I'm going to have to figure out what that angle measure is, but notice I have 104, 43, and 73, so I can subtract those from 360, not 180. And I get that this is 140. Since that's a central angle, this is also 140. Okay, so my arc length is equal to 2 pi times my radius, which is 4, times 140 degrees out of 360. So again, circumference would be the total distance around, but I just want the length from A to D. Okay, I'm going to put that in my calculator since I'm giving an approximate answer. So 2 pi times 4 times 140 out of 360. Make sure you guys are doing this too to make sure you get the exact same answer and you're not putting something in your calculator wrong. So I'm going to say about, since I'm rounding, 9.77, I have no number, we'll just say centimeters. And then that's my arc length. Okay. The next one says, what is the arc length of BAD, or sorry, what is the length of BAD? So that means I'm going from B to A all the way around to D. So if this is 73, then this is also 73. If I add 73 and 140, what do I get? I get 213. Keep your answer in terms of pi means that it needs to be an exact answer. Pi still needs to be in your answer. So maybe try this first, and then you can unpause it, and then watch me do it. Alright, so the arc length is 2 pi times my radius again of 4, but this time I don't want 140 out of 360, I want 213 out of 360. I want an exact answer, so I'm going to do, again, this is like a fraction, so my denominator I know is going to be 360. My numerator is 2 times 4 times 213, which is 1704 pi. And I'm going to divide that by 360, change it back into a fraction, and I get that my arc length is 71 pi out of 15. I'm going to again call it centimeters. And there we go. Alright, so that's a couple problems with arc length. That should be enough. Let's now start going back to central angles and inscribed angles and kind of show you some more equations that you can do. Okay, so this problem says that we need to find the measure. Now notice it says measure, so we're no longer talking about an arc length, we want an angle. So if I want to find the measure of arc BC, that would be this. Well, the only way that I can figure that out is if I can figure out what x is. Well, if this central angle right here is 7x minus 7, then that means that this is also 7x minus 7. I can see that this arc actually opens up to this inscribed angle as well. So if that's the case, then I could take 2 of these x plus 14s to equal 7x minus 7. Okay, or I could say half of 7x minus 7 equals x plus 14. It's always easier to double something than it is to take half of something. However, in this case, I could take this and multiply this all by 2, and this all by 2 as well, which actually is the exact same thing that this equation is doing. So I'm going to solve this equation. If I distribute, I get 2x plus 28 equals 7x minus 7. Subtract, I get negative 5x equals negative 35. So x equals 7. Okay, so x equals 7 is going to help us. I'm going to go back to my diagram. So if x equals 7, I'm going to go back and substitute into here. 7 plus 14 makes this 21 degrees, which means if this is 21, I have to double it, and that means that this would be 42 degrees, which means that this would be 42 degrees. So find the measure of arc BC. Measure of arc BC. We should be actually stating our answers, not just leaving them on a diagram. So measure of arc BC equals 42 degrees, and then circle, underline your answer. Okay? Let's try it again. Alright, in this next problem, we want to find 3 things. The measure of an angle, the measure of an arc, and the measure of an arc. Again, notice that they're not arc lengths, it's measure. Well, the only way that I'm going to figure out anything is if I can figure out what x is, which means I need to set up an equation. I cannot set these equal to each other. I cannot assume that they're the same. However, notice that this angle is inscribed as its vertex is on the circle, and notice that it opens up to a diameter, which is this entire half of the circle. So if this is half of the circle, this is 180 degrees, which means half of that, this is 90. Anytime that you have an inscribed angle that opens up to your diameter, it has to be 90 because it's opening up to half of your circle. Okay? So if this angle is 90, I can now set up an equation, and I can say that x squared plus 2 plus 4x plus 11 plus my angle of 90 has to be 180 because that's 3 angles in a triangle summed to be 180. I could also add up these 2 angles and set them equal to 90. I get the exact same thing. So, your preference. I can see that this is quadratic, so I need to set it equal to 0. Combine like terms, I have x squared plus 4x, and then I'm going to move everything over. If I add 2 and 11 and 90, and then I subtract 180, I get minus 77 equals 0. So factor, we knew this was going to come back to factoring eventually. Alright, so I know that this is going to be 7 and this is going to be 11. This has to be plus and this has to be minus. So I get two solutions. I get x is 7 and I get x is negative 11. Don't assume that the negative doesn't work. You need to go back and actually check to see if it doesn't work. However, if you go back and substitute into here, 4 times negative 11 is negative 44, plus 11 is negative 33. You can't have a negative angle, so extraneous doesn't work. Okay, so now this does work, and I'm going to go back now and figure out everything else for this problem. So if x is 7, 7 squared is 49, plus 2, this angle is 51. 4 times 7 is 28, plus 11 makes this 39. Checking your answer would be a good idea. These two add up to be 90, and 90 makes you 180. So it says find the measure of angle C. So I'm going to say that the measure of angle C equals 90 degrees. Again, you need to state your answer, not leave them in the diagram. The measure of arc AC would be this arc right here, which if this is 39, then I would double it. So then this is 78. So 78 degrees. And then the measure of arc CBA would be from C to B all the way around to A. So the only portion then that I'm not doing is this right here. So I'm actually going to do 360 minus 78, which gives me that this is 282. And those are my three answers. Okay, again, state them. All right, two more. Might be a good idea at this point for you to try one on your own and then come back and maybe see how you're doing. All right, so notice that these are two inscribed angles. You have an inscribed angle that's right here. You have an inscribed angle that's right here. Notice that this inscribed angle, if I draw it out, tracing it always helps with your pencil, opens up to this arc. And if I look at this angle, that's 3x plus 20, notice that it opens up to arc BA. So if they open up to the exact same arc, so think about this, if this was 100 degrees, let's say, then this would have to be 50, and so would this, which means that those two angles have to be congruent to one another. I don't know what their numbers are yet, at least, until I figure out x, but I do know that they have to be congruent to one another. So that means that I can say that this angle of 5x minus 16 has to be equal to 3x plus 20. Okay, this would be a good place to pause, finish this angle, and then go back and find the measure of arc BA. So let's solve. I get that x is 18. Alright, if x is 18, I'm going to go back and substitute. 3 times 18 plus 20 tells me that this angle is 74 degrees, which means the other angle should be, but I'm just going to double check. 5 times 18 minus 16. This one is 74 degrees as well. So that means that the measure of arc BA, so arc BA is right here, is double 74. So this has to be 148. Okay. So 148 degrees. That's my answer. Again, state your answer. Do not leave it on the diagram. Leaving it on the diagram means that you're trying to make me assume that you know what an arc is, and I don't want to assume. All right. This next one would again be a good one for you to try on your own and then come back and check your answer. All right. Let's go through and assume that you already did this. So I have same diagram, different expressions, different places. This is an inscribed angle, so with vertex D, and it opens up to arc BA again. Okay, that does not mean that these are equal. They're not central angles. You could always start by setting it up and say, okay, 3c minus 17 equals c plus 1. That's not the case. but you know that you can take half of this to equal this, but half is always harder to do than saying that if I take 2 of these, it becomes 3c minus 17. But you'll get the same answer. Okay, it's kind of like the exact same formula as midpoint when you had 2 segments equal the whole segment, or angle bisectors, just different property. Alright, so we get 3c minus 17 equals 2c plus 2. So that means c is 19. Okay, I need to figure out the measure of angle C and the measure of angle D. Let's change this. Alright, measure of angle C. So I'm going to go back, or sorry, yeah, I'm going to go back and substitute in. So 3 times 19 minus 17. This angle is 40 degrees. So if this angle is 40, half of that makes this angle 20. And then half of this also makes this 20. Okay, so measure of angle C is 20 degrees, and the measure of angle D is also 20 degrees. Right? I told you guys yesterday that one letter for an angle really isn't an ideal thing to do. This one, measure of angle C, there's only one possible answer for C, because remember again, this is not an angle because this is a curved line. This is not an angle because this is a curved line. So the only possible angle when we say angle C is this. However, it would be better to write this angle as the measure of angle BCA. And that way that there's no question that it goes from B to C to A. Okay? Alright, so that concludes your notes. This is what your homework is going to look like. It's going to have some measures. Again, pay attention to whether it says measure or whether it says arc length. You're going to be filling in circles kind of like you did yesterday. If the radius has this, what is the length? Anytime you see length, you should be thinking that it's a part of a circumference, so you must be using arc length equals circumference times some portion. So it's always going to be less than what your circumference is, because you're always going to be taking not the whole circumference, but maybe 5/8 of it, or 200 out of 360, something like that. Okay? Yeah. You can actually pause it here if you guys want and end it, and then you can show the sub that you're done with the notes and then start on the homework, but I thought maybe I would highlight 1 or 2 things in your homework just in case you have a question on it. Would be a good one to do. So I'll do this one. So again, if you think you're fine, you're good, don't listen to this, you can finish the video, but maybe I'll show you this just in case you need to see it. Okay, so circle Z, because that's your center of your circle. The measure of arc DC, so this arc right here is 96. And the measure of angle EFB, so EFB, so this angle right here is 65. Find all missing angles and arcs and label each on the diagram. Alright, so vertical angles is where I would start. This has to be 65. And then linear pairs, or supplementary, this is 115. And 115. Degrees, degrees, degrees. Okay, now, we are going to learn this in the next couple days, but right now, since the vertex of all 4 of these angles is not the center and not on the circle, it's just floating inside the circle, it's not inscribed, it's not central, you're done. Okay? However, if I come to this 96, this is a central angle to that, so that's also 96. This is vertical, so that's also 96. Subtract from 180, and this is 84, and this is 84. Okay, these 2 angles right here are part of a triangle. So 180 minus 84 minus 65. This angle has to be 31. As soon as I find this angle of 31, I would see that this angle is inscribed and opens up to arc AB. So if I double 31, this is 62. Okay. If this is 84, the central angle, then EC is also 84. If this is 84, then AD is also 84. If this angle, the central angle, is 96, then that means that going from A all the way around to E has to be 96. So 96 minus 62, this has to be 34. Or you could do, this is a diameter, you could do 180 minus 84 minus 62 would leave you with 34 degrees. But you can always double check it. That's an easy way to check to make sure that your thinking is right. Okay? If this is 96 right here from C to D, that's inscribed to this. So 96 divided by 2, this is 48. Okay? If this is 48, then this has to be 48 as well, because this is a radius and this is a radius, which is an isosceles triangle, so those two have to be the same. You could check to make sure and do 48 times 2 plus 84, and that is 180, so we're good. And I think that's it. Yep, so that's everything. That's all your angles and all your arcs. All right? All right, so I will be back on Monday. I will see you guys then. Please make sure that you guys get number 1 and number 2 done. Check your answers. Make sure that over the weekend you do not fall behind in the first 2 days. All right, look for your homework or your test to be graded later today. All right, have a good weekend, everyone.